In this video, let's continue practicing power rule. Let me remind you what power rule says. X to the n will be differentiated, and the result will look like n x raised to the n minus 1. For the function we have, I kind of don't like how it's written as 2 over x and 4 over x squared. Remember, you cannot just differentiate the denominator by itself. So let's rewrite this function. Let me show you that actually we are working with 1 over x multiplied by 2, and we are working with 1 over x squared multiplied by 4. Thus, we can rewrite each term with the negative exponents. 2 is now multiplied by x to the minus 1, and 4 is now multiplied by x to the minus 2. And all of these terms will use power rule. Power rule when we differentiate them. So this is the end of me rewriting the original function. Now I will find the derivative of this original function, f prime. What happens to 7 when we differentiate it? Derivative of a constant standing by itself, isolated, is 0. Plus. So remember, the difference between a constant being let me put any random constant k. A constant being added to a function, when we differentiate this sum or difference, doesn't matter, then it will be 0 plus or minus the derivative of the function. But if constant is multiplied by a function, then it survives because it's a rate. And now you just need to differentiate the function and multiply it by the constant that survived differentiation. And in this case, it's a rate. While in the previous case, it was a constant, isolated constant. How fast does the constant change? How fast does the 7 change? It doesn't change, so its speed is 0. Good. The constant 2 and the constant 4 are multiplied by functions. So like in the second case in this box, this is the box, they will survive. So we're going to write down 2. Now I'm going to change the color. What happens to the x raised to the minus 1? Based on the power rule, minus 1 goes down. Please put parentheses. It will help you in general, it will help you to avoid mistakes. X is now raised to the minus 1 and minus 1, and that is minus 2. Close the parentheses. Plus rate 4, let's write it down, and now open parentheses. X to the minus 2 becomes minus 2. X is raised to the minus 2, and minus 1 is part of the formula. Decrease the power by 1. Again, when you become very familiar with all the formulas, you can write down it right away as x to the minus 3. So we have 0 plus 2 minus x is raised to the minus 2. And I wanted to show you that this term used to be 1 over x, or x to the minus 1, before we differentiated it. X to the minus 1 became minus x to the minus 2. Plus 4, and we have negative 2x to the minus 3. This term, negative 2 times x to the minus 3, used to be 1 over x squared, or x to the minus 2. So look at it carefully and see that it does make sense. Now let me collect the coefficients. Minus 2x to the minus 2 minus 8x to the minus 3. That is a beautiful answer. You can use it to type in your homework program. Maybe they are asking you to answer with positive exponents. That's not a requirement usually, but let's do it. Then it will be negative 2 over x squared. See what I'm doing? The negative power puts x to the denominator, and I'm changing it to the positive power. Minus 8 over x cubed. And I did the same thing with the x to the minus 3. It became 1 over x to the positive 3. Both are equally good answers. Hopefully that makes sense. Practice more with coefficients and practice more with the functions that has any kind of power. Not just minus 1 and minus 2, but 1/2, negative 3/4, maybe even pi. What do you do in those cases? The more you practice, the better you become. with differentiation. Good luck!